this video lecture, we are going to learn about something called percent composition. You will want to have a periodic table and a calculator nearby. So let's talk about what percent composition is. Typically, we are going to be learning about percent by mass, but you could do percent by volume as well. But predominantly, we will be doing percent by mass problems. And essentially, percent composition is how much of the part of something you have divided by how much of the whole thing you have. So we define it as the percent by mass of each element in a compound. The equation, percent composition, and I'm going to abbreviate that as percent comp. Percent composition is the mass of the element over the mass of the compound. And then all you need to do is multiply by 100 to put it into percent form. You do this for every element in the compound, unless you are specifically told to find the percent composition of a specific element in that compound. Now, this equation can also be found on reference table T under percent composition. Percent composition by mass is the mass of the part divided by the mass of the whole. Right? In this case, the part that we are working with today is the element, and the whole that we are working with today is the compound. So this is sort of a generic percentage equation. We are putting specific terminology on it because we are finding the percent by mass of each element in a compound. And so these problems can be presented to you in one of 3 or 4 ways. And I'll show you how, the remainder of these notes will take you through each of these example types. Okay. Actually, I think we're going to do 2 of these example types, and then, 2 of these example types, and then other examples will be in the later lesson. Okay, so example 1, if you have a compound containing only 222.6 grams of sodium, so there's your element, and 77.4 grams of oxygen, there's another element. So those are the only 2 elements in the compound. It says to calculate the percent composition of the elements in the compound. So here we are given the masses of 2 different elements. And so we're going to do this twice. We're going to do this once for sodium, and we're going to do this once for oxygen. We have the masses of each element. What we don't have is the mass of the compound. But we can get that because law of conservation of matter tells us that the mass of the compound is the sum of those 2 numbers. So we are going to do this as percent sodium and percent oxygen. We'll do 2 separate problems going across. So percent sodium, the mass of just the sodium is 222.6 grams divided by the mass of the total, right? If we do a little side calculation, 222.6 plus 77.4, add those 2 together, right? We could do this. We could probably do this in our head, but oh, look at that. It works out to exactly 100.0 grams. That doesn't make any sense. 222.6 plus 77.4. The whole thing comes out to 300. Okay, so somewhere along the way I typed something wrong. All right, good catch. 300.0 grams is the total mass of the compound. All right, so we are going to now multiply that by 100. Doing this in our calculator, 222.6 divided by 300, multiply by 100, and we are going to get 74.2. And what we're going to do is we're going to do this to 4 significant figures because our measurements here both had 4 significant figures. Now, percent oxygen, If you know, understand percentages, you know that the remaining balance out of 100, if you take 100 minus 74.2, you're going to get the percent mass of the oxygen. But the correct way to show your work and to check your work is to take the mass of the oxygen that's given, divide it by the mass of the entire compound, multiplied by 100, right? And so when we do this, we are going to see that we are going to get exactly what you'd predict, which is 25.8%. Now we're going to leave that at 3 significant figures because of this. Okay, so correct way to finish this, we have 74.20% sodium and 25.8% oxygen. The check for sure is to recognize that these two numbers, when we add them together, should work out to be exactly 100%. Okay. All right, now let's take a look at another problem. It's a twist on the same type of problem. What is the percent composition of the compound formed when 2.70 grams of aluminum, so there's an element, mass, combines with oxygen to form 5.10 grams of aluminum oxide? So this is the mass of our compound. What we don't know is the mass of this element. Right? We don't know that. But we can figure that out because the mass of the compound minus the mass of the element will give us the mass of the entire of the oxygen. So 5.10 was the aluminum oxide, Al2O3. 2.70 was the mass of aluminum, and therefore the mass of the oxygen is going to be the difference between those two numbers. So that works out to be 2.40 grams. Okay. And so we are going to say, we've got two problems. We need to do the mass of aluminum, and we need to do the percent of oxygen, percent aluminum, percent oxygen. Aluminum, we decided, was 2.70 grams of aluminum divided by the compound of 5.10 grams. Right? We are going to get 2.7 divided by 5.1. We're going to get 52.9. Yeah, 52.9% aluminum. Oxygen, we know the mass of the oxygen is 2.40 grams divided by the mass of the compound, 5.10 grams, times 100. And when we do this in our calculator, 2.4 divided by 5.1, we are going to get 47.1% oxygen. Okay, so there is our percent composition. We had to make use of the law of conservation of mass in an equation. The mass of the reactants equal the mass of the products. Okay, so that's essentially how you calculate percent composition from mass data. You're given the mass of the elements and or compounds, reactants and or products, and that'll help you figure it out. Okay, so let's take a look at strategy number 2. You're not given mass data, and this time you are given a chemical formula. You're just given a chemical formula. You're not given any kind of mass. So our first example here is you have propane C3H8, the fuel commonly used in gas grills and in home heating. This is one of the lighter compounds obtained from petroleum. We are being tasked with calculating the percent composition of the elements in propane. So our elements are only two. There's carbon and hydrogen. So we're going to say percent carbon and percent hydrogen. And what we need to do is use the periodic table, right? So we know that carbon from the periodic table has a mass of 12.0. We're getting this to the nearest tenth from right here. But there are 3 carbons in the formula. So 3 times 12.0, of course, is 36.0. Hydrogen, we have 8 of them. Each one is 1.01. for 8.08. So when we add those two numbers together, we are going to get 44.1 as our, I believe, right? 36 plus 8.08. We have to round that to the nearest tenth if we're following sig fig rules. So C3H8 has a mass of 44.1 grams, if we're talking about the molar mass. Okay, so percent carbon is the mass of the carbon divided by the mass of the whole compound. So 36.0 grams divided by 44.1 grams times 100. Hydrogen is going to be 8.08 grams divided by 44.1 grams times 100. 36 divided by 44.1 times 100, and we are going to get 81.6% carbon. And 8.08 divided by 44.1, we are going to get, times 100, we should get 18.3% hydrogen. Now, if you take a look at these two numbers, they are not going to add up. They're going to add up to 99.9. That's quite all right because we are rounding to sig figs. There's a little bit of a rounding difference just due to that, and that's just fine. All right, let's take a look at example number 2. Example number 2 gets perhaps a little bit more complicated, only because you have a more complex formula. But we have ammonium phosphate. It is often used as a fertilizer for its nitrogen and phosphorus content. What is the percent of nitrogen and phosphorus in this compound? So there are actually 4 elements: nitrogen, hydrogen, phosphorus, and oxygen. But they are only asking us to find the percent of nitrogen and the percent of phosphorus, because those are the ones that are most important to the fertilizer industry. So let's set that up, percent nitrogen and percent phosphorus. We still need to do we need to figure out the molar mass of this, which means we do have to account for all the hydrogens and the oxygens as well. But I'll do the side calculation down here. For nitrogen, we have 3 nitrogens. Each one is 14.0 grams per mole, right? And so that's going to be, it should be 42. Yep, so 42.0. Hydrogens, there are 12 hydrogens, each at 1.01. So this is going to be 12.12. Phosphorus, there is 1 phosphorus, and phosphorus is an interesting one. Rounding gets a little confusing, but if you round this to the nearest tenth, it is 31.0. This is a commonly rounded incorrectly element, 31.0. And then oxygen, we have a total of 4 oxygens, each at 16.0, so that's 64.0. So if we add all of these up, we're going to have 42 plus 12.12, did that wrong, 42 plus 12.12 plus 31 plus 64. Rounding to the nearest tenth, we're going to get 149.1. That's the mass of NH4,3PO4. Okay, so now once you've done the molar mass, right, once you've done this molar mass, this problem becomes very simple. This is really where all the grunt work is. So mass of just the nitrogen is 42.0. We're going to divide that by the mass of the entire compound, 149.1 grams, multiplied by 100. Doing that in the calculator, we're going to get 28, going to 3 sig figs, so 28.2%. Nitrogen. Phosphorus. We've got 31.0 grams divided by 149.1 grams multiplied by 100. In the calculator, let's do it. 31 divided by 149.1 times 100. You're going to get 20.8. 1 of 3 sig figs. 20, right? 20.8% phosphorus. So there you go. That's how you go about finding percent by mass from a chemical formula. We also saw how to find percent composition from if you are given mass data. All right, that's it for this video lecture. We'll see you back in the classroom.